Bismillahirrahmanirrahim. Today is our topic transformer working and its concepts. Because we are studying polyphase circuits. In polyphase circuits, transformer is involved. Transformer, three-phase transformers is involved basically. So we must know the basics of transformers, transformer workings, and transformer working principle. So today we cover transformer in our lecture, transformer types, transformer working principle, single phase transformer, ideal transformer, leakage flux, transformer losses, BH curve, that is hysteresis loop, power transformer, distribution transformer, and finally auto transformer. So what is a transformer is? Basically, transformer is a machine which transforms electrical energy from one circuit to another circuit. It does so with without the change in frequency actually. Actually, two coils, they are wound on a core. Supply is given to primary side and output is taken from secondary side. So the supply given to transformer is AC supply, and due to supply nature of AC voltage given to transformer windings, and AC current induced due to AC voltage, and an AC magnetic flux produced due to alternating supply. What happens that supply that flux links with the secondary coil, and voltage is induced in that coil. That is Faraday's law of electromagnetic induction. What is Faraday law? Whenever there is a change in current in one coil, a voltage is induced in the other coil. I repeat, when a current is changed in one coil, a voltage is induced in the other coil. This is Faraday's law. And the opposite of that is Lenz's law. What is Lenz's law? The induced voltage in a coil due to first coil induces the voltage in that coil which opposes its causes. This is Lenz's law. For example, you give the supply to a coil, a voltage is induced in that coil due to supply, and due to that induced voltage, a current will flow in that coil, and that current flow will produce its own magnetic field, and that field produces a induced voltage in that coil which opposes its causes, that is supply voltage. So this is Lenz's law. So transformer working principle is based on Faraday law and mutual induction. Mutual induction means that two coils are isolated from each other. There's no physical contact, but only contact is magnetic flux lines which links from one coil to the other coil. This is transformer action. In transformer, we have two sides, primary coil and secondary coil. Supply is given to primary side and voltage is induced in the secondary coil. Transformer purpose is to step up or step down the voltage. So we transformer used for step up the voltage. Either we need to step up the voltage, that is voltage going to step up for transmission purposes, or a step down for utilization purposes. Later on we will discuss in detail. Here another term, magnetomotive force, that is ampere turns. That is number of turns on a coil, and amount of current flow is ampere turns, and that produces a magnetomotive force in a coil. One is electromotive force, EMF, and one is magnetomotive force. So transformers types are step up, step down, three phase, single phase. We have power transformer, distribution transformer, instrument transformer, two winding, one winding transformer, indoor transformer, outdoor transformer. The uses, as I said earlier, step up for the transmission purpose. When we want to transmit our electricity, we step up the voltage to a high value of voltage and transmit the electricity by using a step up transformer. Step down transformer for utilization of electricity, that is utilization of electricity when supply given to the consumers are domestic, commercial, and residential, maybe agricultural. So when supply is given to consumers, they need single phase and three phase supplies, and single phase and three phase supplies are possible from distribution transformer. So single phase for small scale purposes, and the toys, the children toys, and some different power supplies. And three phase used at large scales, transmission, industrial purpose, transmission, and so on. And power transformers used in electrical grids to step up for the purpose of transmissions, and they are rated in MVAs, that is megavolts amperes. Distribution transformers are used to feed the loads, to feed the single phase load, to feed the three phase load, single phase loads, domestic loads, commercial loads, and three phase loads, industrial loads, agricultural loads, and so on. Instrument transformer used for relaying, protection, metering purpose, because instrument transformer is just the name, that is current transformer and potential transformer. You will learn this in detail. Then the detail of this you will learn in your second year instrumentation subject. But here is just intro. So instrument transformer, current transformer, step down the respective current. Voltage transformer, that's potential transformer, step down the voltage and gives the signal to the metering, that is for metering purpose, and meter will record accordingly the currents or volts. Similarly, auto transformer, it is one winding transformer. It deals in EHV, means extra high voltage. Extra high voltage range start from 120 kV to 30 kV, for 365 kV, 500 kV, and so on. Indoor transformer, which are present inside the substation, that is covered area. And outdoor transformer are example, that is pole mounted transformers. In daily life we see at our homes, on the roads, on the streets, we can see pole mounted transformer, that are distribution transformer, that distribute the electricity. They step down 11 kV to 400 volts. 11 kV is distribution network of WAPDA and K Electric among the Pakistan. Magnetomotive force, ampere turns. Actually, what is magnetomotive force? It's the strength of magnetic field, and it depends on the number of turns of the coil, and amount of current flow in that coil. So normally, if we have more number of turns, then we use thinner wire, and if we have lesser number of turns, we use thicker wire. Remember, thinner wire have larger resistance. Thinner wire allows less current to flow, and thicker wires have larger dias, so they allow more current to flow. So magnetomotive force can be achieved by either you increase the number of turns of the coil, or you increase the current, but not both. So this is economical actually. So when, for example, in our step down transformer, our primary coils number of turns are more than secondary, because step down. So secondary side, the voltage step down to some value, so there is no need of number of turns to be greater on secondary side. So primary side, there are greater number of turns because it deals more voltage, and secondary side it deals low voltage. But remember, when the step down transformer is used, the secondary side voltage is less, but the current is more. That's why the dia of the conductor increases when lesser number of turns of coils are used. When more number of turns are used, the dia of conductor is lesser, that is thinner wire. So you can see the terms, that is magnetic field intensity, magnetic flux, reluctance. Reluctance is the opposition of the flux. Flux lines can flow in the air also, like in transformer. But in transformer there is a iron core is used. So core is a permeable material that allows flux lines to link the coils and it gives low permeable path to a flux lines to link with the other coil. Similarly, flux density, and flux density is simply the total flux divided by the cross-sectional area of part through which it flows. The unit of flux is Webers, and flux density. Later on, we study the BH curve in which we monitor what is flux density, what is magnetic field strength, and how they behave. Actually, this links with the hysteresis and eddy current loss. So hysteresis loop, we see how magnetic motive force rises then decreases. So later on, we'll see in our next slide. Yeah. So let's discuss the ideal transformer. Ideal transformer is that in which the entire flux of one winding links with the second coil. That means no leakage of flux. But in practical, yes, there is leakage of flux also. That means not 100% the flux generates from one coil links with the other coil. There are some losses. So in ideal transformer, the losses are zero. So efficiency is 100%. And the number of turns ratio, that is the number of primary coils and the number of secondary coils being same. But this is ideal transformer, not practical transformer. Ideal transformer, yes, the number of turns same and there is no leakages, the efficiency is 100%. Single phase transformer, in single phase transformer we have a coil primary, we have primary side and we have secondary side. Primary side, the supply is given to primary side, and the supply is sinusoidal, that is AC supply given to primary coil, and due to AC supply, AC current will flow in the windings of primary, that is the nature of current is also AC, and AC flux will generate due to AC supply, AC flux. AC means variable flux, right? AC means variable quantities. So magnetic flux, see the green lines, the magnetic flux which generates due to sinusoidal supply, due to sinusoidal current, due to and the final result is sinusoidal flux. That variable flux starts to move inside the core. This is the core of transformer. The flux moves in the core and it links with the secondary coil. See, the flux links in the secondary coil and it induces a voltage in the secondary side. A voltage will induce due to linkages of this is Faraday law. And that induced voltage opposes its causes, that is primary side. It is Lenz's law, as I have told earlier. So this is primary side. Normally supply is given to primary side and load is connected to secondary side. Let's talk about the leakage flux of the transformer. See, there is some flux. There is some flux which leaks actually. That flux goes into the air and does not links with the secondary coil. So this is leakage flux. You see, there are several paths of fluxes. Why there are several paths of fluxes? To understand this, you need to consider transformer behavior on load. Let's suppose the secondary side is connected with the load, and primary side is connected with the supply. So when the load is connected on the transformer secondary side, what happens? A current will flow through that load, and that current flow produces its own magnetic field and starts to move in the transformer, and that magnetic field opposes the primary magnetic field from supply, Lenz's law. So there are several paths of flux, but finally the flux will have only one path, that is the counterbalance, and the flux, one main flux revolves inside the transformer for transformer action. Transformer types, we have core type transformer, we have shell type transformer, core type transformer, and shell type transformer. See the construction. The core type transformer, the core surrounds, the windings surround the core. And in shell type transformer, shell type, the core surrounds the windings. See, windings are inside the core. Windings are inside the core. And here, the windings are outside the core. Windings surround the core. It has several magnetic field paths. That is, core type have several magnetic paths, while shell have only one magnetic path around it. It's clear from the figure. And they have certain applications, core type and shell type transformer, and the construction. These are the types according to construction of transformer. So let's talk about the application. The core type winding putting insulation to easier. In fact, low voltage winding itself acts as an insulation between high voltage winding and core. Whereas shell type transformers are popular in low voltage applications like transformers used in electronic circuits and power electronics converters. So mostly the core type transformers are popular in high voltage applications like distribution transformer, power transformer, and obviously auto transformers. Now let's discuss about the losses of transformer. The losses of transformer are core losses and copper losses. Copper losses occurs in windings of the transformer. There are two types of windings, primary windings and secondary windings. Core losses occur in the core of the transformer. Cores used for the transportation of magnetic flux lines. Coppers are used for the transportation of current. So core losses, we have two categories, that is eddy current loss and hysteresis loss. We will discuss later in this lecture. Copper losses in primary copper loss and in secondary copper loss, because we use copper at two places, that is the transformer primary side and transformer secondary side. So continue, we can see the hysteresis loop, that is transformer uh, core losses, that is eddy current and hysteresis loss. So first we discuss hysteresis. What is hysteresis? To understand hysteresis, we need to understand the this BH curve loop, that is magnetizing force and flux density. On x-axis we have magnetizing force, and on y-axis we have flux density. Now see how this occurs when we give AC supply. AC, this is sinusoidal AC supply. AC supply. Then, when positive cycles of supply comes, then core is magnetizing. See, core core magnetization occurs in positive direction. Core magnetizes in positive direction, and it magnetizes up till maximum of the current, and then it demagnetizes. Means the return path of the flux, it demagnetizes. See, the current decreases and the core demagnetizes. As soon as current increases, the core magnetizes and it goes to up till its saturation. Remember, every material has some saturation level. So when saturation level comes, either you increase the number of turns or you increase the current. The flux will never increase because the material saturates actually. So when material saturates, you cannot increase furthermore. So first the flux increases in a positive direction due to increase of current. The flux increases, and when current decreases, the flux also decreases. See, the flux, this green line, flux starts from some initial value. So what happens? Why does not start from zero? The reason is that there is residual flux. Residual flux is that flux which present inside the coil. We must know the property of the coil. When the supply is given to a coil, a voltage is induced in that coil, a magnetic field is produced. So that the coil property, due to property of that coil, it, it retains some magnetic field inside. So that retained magnetic field remains inside the coil. That's why it does not start from zero. It starts from some initial value. And goes to final and comes back. So this is due to residual flux. Similarly, there is some resistivity, conductivity. We must know these properties: relativity, permeability. So now discuss the negative cycle. Negative cycle. When negative cycle comes, what happens? The flux, the negative current increases. The flux increases and goes to negative maximum value, and finally it saturates. And when current decreases, the the flux decreases and comes back to its original position. Like, see, sinusoid is cycle actually. So this is also BH curve is a cycle. It covers this whole cycle actually. Positive cycle and negative cycle. Okay, the important thing is what is hysteresis loss? Hysteresis loss is the loss which occurs due to reorientation of magnetic domains. See, when current reverses at this point, the, the current reverses, the magnetomotive force also reverses, the flux reverses. So reversal of magnetism is permissible due to at some cost actually. That cost is loss actually. So reorientation of magnet means the magnetic domains are aligned in one direction. The magnetic domains are aligned in one direction due to positive cycle. Then magnetic domains are realigned again in some, that is negative cycle. So reorientation of magnetic domains at some cost is hysteresis loss. At this point some losses occur, which is hysteresis loss. Eddy current loss. Eddy current loss occurs in the core actually inside, and core are laminated. See, these are these are the thin bars. Core is not completely one box actually. It is thin laminations. Different thin pieces are joined together to form the core. What is eddy current? Actually, when flux links with that core, the voltage is induced inside the core, because Faraday's law say when flux links to a core, a variable flux links to the core, a magnetic field, a voltage is induced, and induced voltage, a current will pass. So due to induced voltage in the core, an eddy current will pass inside the core. So if we laminate our core, that is, we cut our core in thin lamination pieces, the current will be minimum to each and every lamination of the core. And as soon as the laminations are thin, the current will be minimum. We know that thinner conductors have lesser dia, so less current to allow. So thin lamination. So eddy current loss depends upon the laminations of the thickness of the material, that is thin or thick, and hysteresis loss depends on the material, that is high silicon material or any other material in which reorientation of magnetic domains are allowed quickly. So both these losses depends on there. One loss is that hysteresis depends upon material of the core, and eddy current depends on the thickness of the laminations. Let's discuss power transformer. As you've seen in the figure, power transformer is used in electrical grids for large power handling. What happens actually when we generate electricity, that electricity being stepped up by power transformers for the transmission purpose of electricity. Our generation is 11 to 22 kV, and our transmission is, that is high voltage transmission, 132 and 230 kV are the networks in K Electric throughout Karachi and Wabda. We have one network of 500 kV, which goes from Hapko power station to Jamshoro. So we have these are extra high voltages, and that are handled by power transformer. Power transformer is rated in MVA, that is megavolts amperes, and in power transformer we see we have three lines because all three phases are transmitted. There is no neutral, no need of neutral. This is transmission voltage. So just we transfer three phases on the lines: red, yellow, and blue. We transmit through power transformer. Power transformer involved at two places, one at generation phase and one at grids. Means one for the transmission purpose, one for the distribution purpose. Means the network which converts from 11 kV to 132 230 kV, and again that 132 and 230 kV converted to 11 kV. Both are in both places we use power transformer because large power handling. After 11 kV we use distribution transformer. This is a distribution transformer. In daily life, you can see outside your streets, outside your homes, roads. This is pole-mounted transformer, that is distribution transformer. Incoming of this transformer is 11 kV. This is 11 kV, right? 11 kV distribution network. The primary side of this distribution transformer receives 11 kV, and the secondary of this transformer gives 400 volts phase to phase, 220 volts phase to neutral. So from distribution transformer we have two options: three-phase supply and single-phase supply. So distribution transformer, the purpose of distribution transformer is to make the transmission voltage to utilization voltage, and that job is done by distribution transformer. So distribution transformers are used, and the capacity is normally in kVA, kilovolts, amperes. They start from 25 kVA to 500 kVA. Different transformers. Usually in Karachi, we have 250 kVA and 500 kVA distribution transformers. Because I was in K Electric in 2005 and 2006. I was at the project of pole-mounted transformer installation of check meters. So our team installed check meters overall in the Karachi on 6,000 PMTs. At that time, our team successfully installed check meters on pole-mounted transformers, distribution transformers. So uh, I visit, I almost see the each and every corner of Karachi due to that project. I was assistant executive engineer at that time in K Electric. We installed check meters, and check meters for the purpose of theft, actually, how much units are generated and how much billed from that transformer. So theft was another department, not mine. We just installed the check meters, and we also remove the loose connections, rehabilitation of the network, 11 kV network, and HT network. HT means high tension, 11 kV. LT means low tension, 400 volts. Low tension network is more dangerous. Why? Because low voltage side, the amperes are high. As I've said earlier, when transformer is used for step down, it step down the voltage, but it amperes rises, its current rises. So LT side is dangerous. Low voltage side is dangerous due to high amperes. So the distribution transformers are used. We see. Remember that transformer efficiency, it is not ideal practical transformer, so its efficiency remains 96-97%. Why? Because in transformer, the energy form is not going to be changed. That is, electrical energy cannot be converted to mechanical by transformer, or mechanical energy cannot be converted to electrical by transformer. That job is done by generators. Transformers just change the voltage levels. So it does so without a change of frequency. So it has its efficiency is almost above than 95 because energy form is not changed in transformers. And transformer is a very efficient device to do this job. That is, either you step up or step down your desired voltage. Step up for transmission purpose, step down for distribution purpose. So transformer is efficient device to do that. So in transformer we have cooling purpose also. Transformer oil inside this conservator tank. It contains transformer oil. Transformer oil has two functions. It cools the windings and it gives insulation. We need insulation of windings to be perfect, and we need cooling of the windings because windings are always get heated due to current flow. So we need cooling purpose. So conservator tank have the transformer oil which circulates inside the transformer and the windings are dipped in the coil. Sorry, coils are dipped coils are dipped inside the oil. Okay, last thing about this distribution transformer, how you identify that this is 11 kV side and this is 400 volt side. So if you see the three conductors, that is HT side bushing. Bushing means connections. The three connections at HT sides tells you that this is HT side, and the fourth wire, that is when you see four bushings, that is fourth one is neutral actually. So you identify the fourth one, you see that that is the secondary side, that is utilization side. So when you see three wires, that is three phases, red, yellow, blue, and when you see four wires, then there is the fourth wire is neutral, and if you see fifth one is for the earth for the production actually. So neutral is needed for secondary side to fed the consumers, and single phase consumer is fed by phase and neutral, and three phase consumer is fed by directly three phases. So the last one is auto transformer. Auto transformer, we have one coil, one coil. There is no isolation between the primary and secondary. So what is the advantage of this auto transformer? Auto transformer, we have a variable, this pointer, it moves up and down. If you want if you move the pointer downwards, you will get lesser number of turns, you will get lesser voltage across the load. If you move the pointer upward, you will get more voltage. So continuously you change the voltage, variable voltage is available across an auto transformer. An auto transformer is used where extra high voltages are there. That is, for example, a network which converts from 132 to 230 kV, auto transformer is used, or the network in which we need to convert 230 kV to 132 kV, we used auto transformer. Another use of auto transformer has many uses and applications. Another use including the starting of induction motor, because induction motor needs voltage, that is variable voltage. Uh, Motor needs to start, so auto transformer is used to regulate the voltage of the transmission line and to start the induction motor. And the use of auto transformer is beneficial. So this is end our week 1 lecture. I hope you understand, and you make a notebook in which you note down the lectures. And we'll meet in the live sessions, and your queries will be entertained over there. So be ready and be prepared, and make a lecture copy, lecture notes of the circuit analysis, especially my topics that I have covered in my week 1 lectures. I will also upload some handouts for you that you should make a lecture copy, and that helps you, that grips you on the subject. You should make a lecture copy, lecture notes for your own understanding, and for any queries or any questions, any queries, we will meet in the live session. We will discuss. In the next class, in the next lecture, we will do the numerical problems on polyphase. And then good luck to all, and have a nice day. We'll meet in the live session soon. Thank you.